ask that you read through the definition thoroughly on the integral test. But once again, it does have three requirements for f. It must be continuous, it must be positive, and it must be decreasing. One more example. Suppose that we work with the natural log of n over n as a series. And again, we are doing an integral test, so we would carry out the integral. We might want to go off to the side and refresh our memory on this integral, natural log of x over x, and recognize that we would do a u substitution to accomplish this integral. Let u be the natural log of x, and then du would be the 1 over x dx, giving us the integral of u du, antiderivative u squared over 2 plus a constant, in other words, natural log of x squared over 2. Again, with that in mind, we would like to perform the integral test on this particular series. We would then compare it to the function. So the function is the natural log of x over x, and we would need to think through, is it continuous? Well, it would not be continuous at 0, but we are considering values from 1 on up, so it would be continuous in that region. Is it positive? Well, past 1, the log graph, if we think about that log graph, past 1, the numerator, of course, the log would be positive, and of course, past 1, x is going to stay positive as well, so it would be continuous, it would be positive. The question is, would it decrease? And so if we think about f of x as this function, natural log of x over x, we could examine its derivative and see if it's negative. So if the derivative would be negative, then it's decreasing. That does require a quotient rule. So let's clear some space and carry out the quotient rule to show that it would be decreasing. So f prime of x would be the denominator squared, and it would be denominator times the derivative of the numerator. Derivative of natural log is 1 over x, minus the numerator times the derivative of the denominator, which would just be 1. And we can see that this results in 1 minus the natural log of x over x squared. Would this be negative? Well, certainly the denominator is going to be positive. It would be negative if the natural log is bigger than 1. And that would be true as long as x is bigger than e. So if x is greater than e, the natural log of x is bigger than 1, and then this derivative would be negative. So it eventually does decrease. For many problems, it's an obvious statement that it's continuous, positive, and decreasing, but otherwise we would normally show that it decreases. So once again, the series we're interested in is the natural log of n over n. N goes from 1 to infinity. And what we are going to compare it to is, what does this integral do? Natural log of x over x as an improper integral. We would carry out the normal steps of limit as t goes to infinity, replace this with t. And if we go to integrate this, we would do the u substitution that we previewed a little while ago. And it's true that we would get the natural log of x squared over 2. And we would still need to do the substitution from 1 up to t. So we make that substitution. We get the natural log of t squared over 2. Put a minus sign down. If I substitute 1, the natural log of 1 squared over 2 natural log of 1 is 0, so essentially this drops out. And it is true that this function continues to climb, and so would its square, so it is divergent. And therefore, we have shown that the series would also be divergent. So we could summarize that the series natural log of n over n is also divergent by the integral test.